The concentration in milligrams per millimeter of vaccination in a patient's bloodstream can be represented by this equation, where C is the concentration and T is the time, in hours, since vaccination was injected. For how many hours will the concentration of the vaccination be greater than or equal to 0.05 milligrams or milliliters? Okay, so just have to see when. For how long, for how many hours will the concentration, so the concentration is C of T, is 0, oops, let's get a better color here, 0.36 T over T squared plus 3. So when will that be greater than or equal to 0.05? Alright, there are plenty of ways of solving this, but I'm just going to go with the way I've been teaching so far. So we're just going to bring everything to the left. 0.36 T over T squared plus 3 minus 0.05 greater or equal to 0. So all the places where this new thing is true here are all the places that this is true. It's the same, basically the solutions will be the same. Okay, so all the places where it's going to be greater than 0.005 will also satisfy this new equation. Okay, so let's get a common denominator. Let's say 0.36 T minus 0.05 times T squared plus 3. And now these will both be over T squared plus 3 greater or equal to 0. Alright, now we're going to put that all together. We got 0.36 T minus 0.05 T squared minus 0.15 all over T squared plus 3 greater or equal to 0, which is... Okay, we'll tidy this up a little bit here. There we factored out the negative 0.05 and we put the terms in order. T squared minus 7.2 T plus 3 isn't necessarily that easy to factor, so we can use the quadratic equation and we should get this right here, and we have it factored on the top, factored on the bottom. We have a quadratic on the top, quadratic on the bottom. That'll be easy to graph. We know the horizontal asymptote already. So let's get graphing and then we'll see what the answer is. And then I'll show you a different way of doing it as well. But it's probably easier, but who knows? All ways are good as long as you're getting the right answer, I guess. All right, first thing, we need an x and a y, or t and a y variable, a second variable, before we can graph anything. So we're going to let y equal this right here. There, now we could legally graph and it'll actually be meaningful. All right, what do we know? We know that there's a horizontal asymptote at negative 0.05 over 1, so negative 0.05. There it is. We know that there are going to be zeros at 0.444 and approximately 6.756. About here. There will be no vertical asymptotes because t squared plus 3 can never equal 0, because t squared will never equal negative 3. And y-intercept happens at, let's see, negative 0.05 as well. You just plug in t is 0 and you should get that answer. Okay. All right, so we know that the graph has to come up here and then come down here and then follow this line. And over here, it's going to have to come and follow this line. So there's your graph. Now, what are we looking for? Let's go back up and see. We're looking to see when this is greater or equal to 0. All right, so when does that happen? Well, it looks like it's greater than equal to 0 all through this area right here. So this is anywhere between t is anywhere between 0.444 and 6.756. Now let's reread the question just to make sure that we're answering it properly. Oh, there's the question right there. Kind of wrote over top of it. Yeah, let's move it down. I'm having a rough time here. All right, so it says, for how many hours will the concentration of the vaccination be greater than or equal to 0.05 milligrams? Well, now we don't look for where it's greater or equal to 0.05 in our graph. We've already adjusted and brought the 0.05 to the left. So we want to know, our answer will be when it's greater or equal to 0 in this scenario. Okay, so it's greater or equal to 0 at this spot right here. But it wants to know the number of hours. Okay, well, the number of hours will just be 6.756 minus 0.444, and that's going to be n. I'm going to say let n be the number of hours, blah, 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 blah. And here n equals 6.312. Therefore, the number of hours for which the concentration is greater than or equal to 0.05 milligrams per milliliter is 6.312. All right, let's try another way. Let's do it more algebraically. So again, we want to know when is 0.36t over t squared plus 3 greater or equal to 0.05. All right, so solving algebraically, we can multiply both sides by t squared plus 3, but we really have to be careful not to multiply both sides by a negative number unless we're going to switch the sign. And you can't multiply both sides by something that may be negative and may be positive. Then in that case, you're just going to be ruining your whole equation. But in this case, t squared plus 3, I guarantee you will always be positive. It's impossible for it to be negative because t squared can't be negative. Add 3, it just can't be negative. So we actually have no problem to go ahead and just multiply both sides by t squared plus 3, and we'll get 0.36t greater or equal to 0.05 times t squared plus 3. Bring everything to the left. Okay, notice I had to multiply the 0.05 by t squared and by plus 3, and then I brought them to the left, and it became negative 0.05 t squared and negative 0.15. And put it all in order. Now we can factor this. So I always like to take out the leading coefficient, and this t squared minus 7.2t plus 3 isn't easily factorable, but we've already done it above, and we know that it is. Right, negative 0.05 times t minus 0.444 approximately, and t minus 6.756 approximately greater or equal to 0. All right, now we can graph this one. Okay, remember this doesn't make any sense whatsoever unless we have a y value and a t value. I think I screwed up earlier and I put x and y. I think I'm going to go back and change that as well. So y and t, here we go. Give a little bit of room here. There we go. So I'm going to change this x to a t. I'm also going to change the x to a t up here because that's wrong. All right, that's better. I'm just used to putting x's there instead of t's. All right, and now let's graph. We've got ourselves a quadratic. We know it's facing down because of the negative 0.05. Now we're back into polynomials. These should be quite easy to graph. Let's see, we got a 0 at 0.44 again. 0.444. We got a 0 at 6.756, and we know that it just kind of does this. And sure enough, our solution, whenever it is greater or equal to 0, is still, probably shouldn't scribble it out, let's try it, a highlighter, is still between, when t is between 0.444 and 6.756. So the same answer we got at the top. So the same conclusion as well.